So in this video, I want to look at the product rule for differentiation. And the product rule is the rule that you use when the function that you're working with is a product of two smaller functions. So if we look right down the bottom, if you have an exponential multiplied by some kind of power function, which is what we've got here, if we were working with this function overall, or if we were working with this function overall, we would use a product rule because the overall function is the product of two smaller functions. And so the two smaller functions we designate as u and v. And these two functions will be from the list of differentiable patterns that we've learnt so far. So there'll be a power function, something like x to the power of n. It might be something like e to the something x. It might be a log function in some form or other, or it might be a circular function. And you'll get a combination of two of those multiplied together. Now you can see in the very bottom one here that one of the functions is in fact a composite function. So here we've got cos of an exponential function. So when we're working out our product rule, we'll need to use our chain rule as well. And so these questions will gradually increase in their level of difficulty. So where does the product rule come from? So if I take a normal function, which is a function that is two functions multiplied together, and I find 2 points, x and x plus h, and I find the derivative using first principles, then my y coordinates will be u of x, v of x for this particular point here, because I'm substituting x into this formula. And the y coordinate of this point will be u of x plus h and v of x plus h, because I'm substituting x plus h into the formula. So as you can see, there's a whole lot of substitution into the formula and then a whole lot of other stuff. And I'm not going to go through it with you, but right at the end, you end up with the product rule. So I'll do a video on this, a standalone video on this, and talk you through it if you're interested. But now let's talk about the product rule a bit more. So what's important when using the product rule? Well, firstly, you need to identify the two functions. And it doesn't matter whether the two functions are any type of function, you just need to identify that there are two. Then you need to differentiate both and then combine them into the product rule formula and then simplify where possible. Now, some of you might have seen this version of the product rule, which is what they call the dashed version of the product rule. And so this is a simplified version of the product rule instead of actually having the formal thing written in function notation. They've got rid of the x on all of these and they've ended up like this. Now, it is absolutely best to avoid using this notation in the exams. In the exams, they'll either ask for it in formal function notation with f and then the variable, or they'll ask you for dy dx. So this is kind of a mixture of the two forms and it's not good practice to use it. By all means, remember the product rule this way, but my advice would be not to write it. Don't write it like that in the exam. So let's do an example. So we're asked to differentiate e to the 2x times the square root of x squared minus 1. So you can see that we have two functions here, our e to the x function and our square root of a quadratic. And so our solution process goes, let u equal 2 to the x and v, I've written, you can see, as x squared minus 1 to the power of a half. It makes it easier to differentiate is why I've done that, so that you can see that when you differentiate, the half comes out the front. So differentiating the exponential gives us the derivative of the top, which is just 2 out the front of the exponential that we had. Finding the derivative of this, the half comes out the front, times by x squared minus 1, the power drops by 1 to give you minus a half. And then you multiply by the derivative of the inner which is 2x. Simplifying this, we get 2x on 2 times by 1 over our square root, which simplifies to just x over our square root function. So next step, let's use the product rule. So we substitute into the product rule our u and our v. Let's move this up. Substitute in. And then we go through a process of simplifying. And so I've simplified it so that I have two terms separated by a plus sign in the middle. Now the question is always, how far do we need to simplify this? Do we need these powers written as a square root? Should I take a common factor of e to the 2x out of both of these? My response to that is that if they ask in the exam for a specific form, then give it to them in this specific form. If you have something very simple that you can take out, like this e to the 2x, we can take that out the front and leave us with something like that, then you can go ahead and do that. But my advice would be, if they haven't asked for it, don't do it, because if you stuff it up and you make a mistake and your final answer is wrong, even though it's correct here, if what you've got here is wrong, then you don't get an answer mark. Okay, so if the question is worth 2 marks for a product rule question, they'll be looking for some evidence that you've used the product rule, and then give the answer that you need to give. So sometimes, as I said, the question will ask you to give it in a particular form. And so what I'm going to do is I'm going to continue to simplify this until I get the form that I had when I did it on my CAS calculator. And you'll see how difficult this becomes. So I've taken out a common factor from all of this. Whoops. Let's move this along. And so now I'm going to write these as square roots. And then what I'm going to do is I'm going to write these two terms with a common denominator. So to do that, I need to multiply the second fraction by the square root of x squared minus 1 over the square root of x squared minus 1, which means these two multiply, which gives me 2 times x squared minus 1, because the square root of a times the square root of a is just a. So I then simplify, write this fraction with the same denominator, expand out my brackets, rearrange, and then finally I get what I had on my CAS. And so you can see that all of this simplification is just playing around with the arithmetic and the algebra. So in terms of how far you need to go, be guided by what's in the exam question. If you want to check at this stage up here or at this stage up here on your CAS calculator whether you've got the correct answer, on your CAS type in literally your equation, whatever your equation is, equal to the answer in the back of the book, and press enter. And if it says true, then your answer is equivalent, and move on from there. You do, however, need to be able to do this manipulation if they ask for this in a particular form in the question. So the sort of thing that they would say is they would say, find the derivative of the function and give your answer in the form of, and this would be something like a over b, something over a single denominator.